Hi everyone, I'm going to present MorphyNet, a large multilingual database of derivational and inflectional morphology. I'm Gábor from the University of Trento, and I'm going to present this with my friend and longtime collaborator and the main developer of this resource, Khuyagbaatar Batsuren from the National University of Mongolia. Morphological analyzers, morphological databases have always been used in natural language processing, computational linguistics, and even if the more recent trends have been to use as little linguistic knowledge as possible, these more or less naive and grammar-agnostic approaches have reached their limits in terms of performance, and due to this, the use of high-quality language resources is on the rise again. So, for example, subword segmentation has been a hot topic in the context of word embeddings and language models in order to address the problem of out-of-vocabulary words and morphologically rich languages. One of the most recent lines of research has been to replace the language-agnostic subword segmentation algorithms by genuine morphology-based segmentation. But beyond the domain of artificial intelligence, multilingual morphological data has also been used in linguistics, such as in linguistic typology. Morphological analyzers and DBs have existed for decades. The earlier ones have been manually designed and were monolingual, typically. Some more recent efforts have tried to integrate these to build multilingual resources such as UDER for derivations. Others, such as Unimorph for inflectional data, do it differently. They scrape massive amounts of data from Wiktionary. The last version of Unimorph, for example, covers 122 languages and over 10 million words. And even if these are the multilingual databases that have the best coverage, as far as we know, they can still be improved. So, for example, Unimorph has a very broad coverage of over 100 languages due to its focus on under-resourced languages, but its per-language coverage is not always very deep. So, for example, entire parts of speech are missing for some languages, such as adjectives for Hungarian or nouns for French. Unimorph is, in fact, not exploiting all of the data that is available in Wiktionary. UDER, on the other hand, has support for a more limited number of languages, 20 languages, but it lacks segmentation data. And in general, the linguistic and semantic metadata describing derivations and inflections can be improved, can be enriched. This talk is on a new morphological database called MorphyNet, which tries to fill in most of the gaps that I mentioned. It is, first of all, multilingual, but it's focusing on a smaller number of major languages, on 15 languages in its first version. It is comprehensive in the sense that it is covering both inflections and derivations. It is intended to have a high coverage of the languages it supports, so it's rather narrow and deep and not broad and shallow. We are trying to build it in high quality. We evaluated it to have a precision of over 95% in general, because our goal is to enable applications also in fields that require linguistically precise data. And finally, we are intending it to become a lexicosemantic network, which is why MorphyNet has net in its name. So our intention is to integrate it into the Universal Knowledge Core, which is a huge lexical database that currently covers over 1,000 languages and over 3 million word senses.
Here is our general architecture to create the MorphyNet. And our main source of information is a Wiktionary, so we take the Wiktionary as an input. And our methodology has the two main phases. First is extraction phase and second is enrichment phase. For the extraction phase, first we designed the set of rules for all the different elements of Wiktionary content. Those Wiktionary content includes HTML tables and HTML headword lines, and also raw dictionary templates. And with these extraction rules, we parsed the most content of the MorphyNet, but still we encountered some incompleteness problem. So to overcome those incompleteness problem, we designed the enrichment phase. For the enrichment phase for inflectional morphology, we use the data itself. For the derivational morphology, we use the external resources of Cognate database. And after the enrichment phase, we are generating the MorphyNet. And MorphyNet is a pre-database as dictionary. For dictionary extraction of inflectional morphology, the inflectional morphologies are given in either tables and headword lines. We parse both of them. For the parsing the tables, our methodology is exactly same as the unimorph. For the headword lines, we have the following examples. And so Italian word for banca, first we here in this example, first we parse the feminine singular, and second we parse the feminine plural. And Russian word grazia, here we first parse the passive imperfective, second we parse the passive perfective. For the derivational morphology, the derivational morphology informations are given in the etymology section. And from the etymology section, we parse the source words and derivational morphemes. And other supporting informations of parts of speech of target words and source words are parsed from the headword lines. And after the extraction phase, we still encountered some incompleteness problem. So in this case, we presented this Hungarian word multilingual. So Hungarian word multilingual is an instrumental case of Hungarian word multia. And while this Hungarian word multia is also possessive form of Hungarian word mult. So for those three words, we have following entries after the extraction phase. But here we are still missing the important information, two important information. First one is the root word of the multilingual, which is a mult, and the second one is a possessive morphology feature for the word multilingual. So to overcome this issue, we designed a very simple logical rule. In this rule, if the three words are sequentially related to one another, then child word can inherit the parent word's morphological feature and also root words. So in this case, we enrich the infer the following inflectional entries. And here is the French example. So with this simple technique, we enriched our sources by 10%. For the derivational enrichment, we used the Cognate database of the external resources. After the dictionary extraction phase, let's consider in this example we have two entries, accusation and computational. And one is for English and other one is for Portuguese. So for the English derivational entries, let's consider the two words, source and target words. And let's find their cognates, the Portuguese cognates. And corresponding Portuguese cognates are acusar and acusatio. So now, how do we know that these two Portuguese cognates are morphologically related? To answer this, we simply find the longest common substring and remove them. So leftover substrings now the candidate morphemes. So we look for these candidate morphemes from our database. If we find this morpheme, and we can safely enrich our resources. So this CIAO is we find another Portuguese derivational entry. There is a CIAO morpheme. So with this evidence, we can safely enrich our resources. So with this simple rule, we enriched our database by 25%. And here is the full statistics of MorphyNet. And number of inflectional entries are 25 bigger than derivational entries, because the inflectional morphology is much more productive than derivational morphology. It is a known fact. But number of derivational morphemes are much larger than inflectional morphemes, which was the opposite in the previous ones. It was interesting. So now we have the resources, so we evaluated our resources. First, we manually evaluated over 5 languages. For each language and each different type of morphology, we sampled the 300 random samples and asked the native speakers to evaluate them to corresponding features. And the results are consistently higher than 98%. And then we evaluated our resources against the existing state-of-the-art morphological databases. First one is a UDIR. And UDIR is a derivational morphology database. And the overlap between the UDIR and MorphyNet is less than 10%, which is very good because content of the UDIR and MorphyNets are quite different from one another. And since there is no standard evaluation task, we designed the evaluation task ourselves. And this evaluation task sometimes, for some cases, it can have multiple correct answers. And both resources can have one of the multiple correct answers. So this settings of the task is quite tricky. Even these tricky settings, we accurate very high precisions and kappa score, interagreement score between two resources. And the second resource is a Unimorph database. Unimorph is a inflectional morphology database, and we compared our resource with Unimorph over the universal dependency tree banks as a gold standard task. And our recall is greatly improved over the Unimorph. We think it's just because Unimorph are missing many number of part of speeches, and our precisions are consistently range between 93 and 99.
And to finish our presentation, we would like to offer some perspectives and conclusions. First of all, I mentioned that we are envisaging MorphyNet as part of a large lexicosemantic network. The idea is that morphological data, especially derivational data, can be used to address issues of lexicon incompleteness. We are in the process of publishing a large multilingual lexicon called the Universal Knowledge Core. This UKC is intended both for computational and for regular linguists as a kind of a massive high-quality lexical database. It is already online, you can browse it, and derivations from MorphyNet will soon be imported into it in the form of new words, new meanings, and new morphological relationships. In the second phase, we are planning to import inflectional data as well. So, in conclusion, MorphyNet turns out to be a large extent complementary with respect to existing resources. In terms of derivations, its overlap with UDIR is very low. And in terms of inflections, it extends the Unimorph coverage by about 50% over the 15 languages that it addresses. Discussions are actually on their way about a possible fusion of MorphyNet inflections and Unimorph. And there's also a question of integrating MorphyNet into the UKC. Finally, MorphyNet is already available, downloadable, so check it out through the links below. And thank you for your attention.